This is Mrs. Appiah with Lesson 2 from Grade 8, Module 2, Definition of Translation and 3 Basic Properties. Student outcomes for this lesson. Students perform translations of figures along a specific vector. Students label the image of the figure using appropriate notation. Students learn that a translation maps lines to lines, rays to rays, segments to segments, and angles to angles. Students learn that translations preserve lengths of segments and degrees of angles. The essential question is, what are the 3 basic properties of translations? In this lesson and those that follow, we emphasize learning about translations, reflections, and rotation by moving a transparency over a paper. At this initial stage, with these basic rigid motions, an emphasis provides a tactile familiarity with these transformations. In the next few lessons, we learn about 3 kinds of simple rigid motions: translations, reflections, and rotation. We call these basic rigid motions. We use the term basic because you will see that every rigid motion can be obtained by a suitable sequence of translations, reflections, and rotations. In the following, we'll describe how to move a transparency over a piece of paper to demonstrate the effect each of these basic rigid motions has on the points in a plane. We're going to begin with translations today, or more precisely, a translation along a given vector. Revisiting our opening discussion question from Lesson 1, what is the simplest transformation that would map one of these figures over the other? So, taking a look at it, it's in the same general position where the red section is in the lower left-hand corner. So you might say that we slide it over. So let's talk a little bit more specifically using the vocabulary of a translation. When you want to translate an image, you need to use a vector. So our vector, we start at one point and we end at another point. A vector has direction and length. I extend the vector so that I can see where I'm going to be translating it to. I put the transparency over the original figure and I traced the figure. And this is the same example that we did in Lesson 1. So basically we're just reviewing right here. And go all the way around here. Then I want to move my paper along the vector. Well, I need to grab my arrow as well. And then slide the vector along the dotted line, lining up the end point of the old vector with the starting point of the new vector. And then you have translated your figure. When you're translating a figure, you need to know the direction of the slide and the distance of the slide. So we draw a vector. It tells us both the distance and the direction of the translation. A vector, let's fill in the vocabulary here. A vector is a segment in the plane with direction. And let's add an example to your notes. This first vector, we'll call this vector AB. And we use notation for that, AB. And the first letter is the starting point of the vector, and the arrow points in the direction that the vector is pointing toward the second letter. And in the second one, let's call this one AB. But when we label this vector, you would start with a letter B because B is the endpoint. So this would be considered vector BA, and the arrow would be pointing toward the A. In example 2, we're going to translate point P along vector AB. Take your tracing paper and place it over the image. Trace point P and trace the vector. Since we're using tracing paper instead of transparency, you're going to need to do an extra step. Turn your tracing paper over and off to the side and retrace your vector and your point. This will allow the image to come through when you translate it. Then place
Place your tracing paper back on the original image, making sure to line up the vector and the point. Slide it along the vector and line up the beginning point with the end point. Then trace the original point. Remove the tracing paper. You may need to darken that a bit and then label the image. The original figure was P. The image that you have translated is called P prime. Example 3. Translate the figure along the vector. So we have figure L that we're going to translate as well as these 2 points. This is our vector that we are going to translate the image along. Step 1 will be to trace the vector and all of the figures. Place your tracing paper over the image. You're going to trace your vector and your image. And then since we're using tracing paper instead of transparency, we need to do the extra step of turning the paper over and retracing those lines. So I'm just going to go here and trace each of the lines. You actually don't have to retrace the vector. Then we'll go back and you want to make sure that it's lined up carefully. Now you're going to translate the figure along the vector by moving it along the vector and place the end point with the starting point. Again, this is your end point right here, and when you trace it along a vector, you're going to move it and you're going to slide the starting point to the end point. Then, carefully retrace the figure. Remove your tracing paper and label your figure. This is the figure or the line L, and this will be L prime. Then we can call this figure point Q, and then the image would be Q prime. And let's call this point P, and then this would be point P prime. And you may need to darken your translated images.
Example 4, what are some observations about the basic properties of translations? So here we have our original figure and we have translated it over along the vector. And what we notice is that a couple of things are true. The first thing is, notice that the length of L right here is the same in the image as it is in the figure. The second thing, notice that the angle POQ is the same as in the translated figure. So we have the same measure of the angle. So some observations about the basic properties. The first one is that a point translates to a point, a segment translates to a segment, and an angle translates to an angle. A ray translates to a ray. The second observation about the basic properties is that segment length is preserved. It is the same length in the figure as it is in the image. And the third basic property is angle measure is preserved. The measure of the angle in the image will be the same as the angle measure in the original figure.
Exercise 1. Draw at least 3 different vectors and show what a translation of the plane along each vector will look like. Describe what happens to the following figures under each translation, using appropriate vocabulary and notation as needed. Your directions again for translations. First, you're going to need to draw your vector in this case because they are not drawn for you, and you'll extend your vector. Then, you'll trace the vector and figure. Flip your paper over and trace the figures. Flip it back again and align it with the original. Then, slide along the vector and trace your figure. Label your image. If you'd like to pause the video and try this on your own, feel free to. I'm going to translate image S. So the first thing I want to do is draw a vector to see where my image is going to go. And I'm going to actually make my vector over here. You need an arrow to show direction. Next, you want to extend that vector so that you can slide it along in a straight line. Take your tracing paper. Make sure you've got it covering the figure and the vector. Trace the vector and the figure. Turn over your tracing paper. Trace the other side of it so that you have lead on this side of the tracing paper. Back to the original image, line it up with the vector. Slide the starting point to the end point, making sure this is lined up, and then retrace your figure. Remove your tracing paper. You may need to darken your image. And this was S. This is S prime. If you're comfortable, pause the video and do another translation on your own. So I'm going to do a second one now. I'm going to translate this cylinder. And I'm going to move this one a little bit down and to the right. So I'm going to take my arrow and make my vector. That'll be my start point. This will be my end point. And then I'm going to extend that so when I translate it and slide it along the vector, I can do so in a straight line. Take your tracing paper and trace your figure. And your vector. Off to the side of your paper, you will want to draw over your figure to get lead on this side of the tracing paper. Then you'll put it back, and you want to make sure your vector is lined up. Slide it along the vector so that the end point lines up with the starting point. Then retrace your figure. Remove the tracing paper. You may need to darken that image. The original figure was V. The translated figure is V prime. Sorry, that was my phone, not yours. All right, so you have one more image to do. If you are comfortable with it, pause the video and do it on your own. Otherwise, you can follow along. For my last one, I think I will move the moon down and to the left. So I want to draw a vector with a straight edge. So I've got a starting point and an end point. Then I'm going to extend my vector so that I can move it along in a straight line when I'm ready to translate it. Take your tracing paper, and you're going to need to translate your image or you're going to need to trace your image and your vector. Then take it off to the side, go over your image, and when you place it back over the image, you want to make sure that it's lined up with the image and the vector. Then you want to slide it along the vector so that the original endpoint is then the starting point. Slide it along. Okay, so now the starting point of the vector is the end point of the old vector. Then retrace your image, remove the tracing paper, and label your image. So the original image was called R, and the translated image is R prime. The notation to represent the image. We started with S, and that translated to S prime. We translated V, and that translated to the image V prime. And we translated figure R, and the image is R prime.
Exercise 2 on your own. The diagram below shows figures and their images under a translation vector HI. Use the original figures and the translated image to fill missing labels for points and measures. So our vector for translation was this vector here, and what that means is that all of the figures will have moved down and over to the left just a little bit. So this was our first figure, and then the image is here. Then you think, how do you know which one was the first image and which one is the translated image? The image will have the plain letters F and C, and the translated image will have the labels F prime and C prime. So this point F translates to F prime, and the other point on the segment is C prime, and so then the original figure would have been C. And again, the direction of the vector shows us from the starting point to the end point, so it would make sense that your figure would start up here and move down here. Then our other translated image. So we've got angle ABC right here, and we've got our other angle here. And you think, which one is the translated image? Well, look at the letters. Which ones have the prime symbol? The angle at the top is measure ABC, and that does not have primes. So then the second one below would be your translated image, A prime, and then B translates to B prime, and C translates to C prime. Notice that this is a 31-degree angle. The angle measure in the translated image will also be 31 degrees because the basic properties of rigid motions are that an angle measure is preserved when you translate it. Then we also have a 5-centimeter segment, and on one side it is labeled E, and on the other side is unlabeled. So if we translated that image, we translate our image along the vector by moving it along, and then we see that our segment length is preserved. So our original segment, which was called DE, and our new segment, or our image, both of those are 5 centimeters long. And the missing label on the right side is E prime. Remember that a point translates to a point, a segment translates to a segment, segment lengths are preserved. In this lesson, you have learned a translation occurs along a given vector. A vector is a segment in the plane with direction. One of its two endpoints is known as a starting point, while the other is simply known as the end point. The length of a vector is, by definition, the length of its underlying segment. Pictorially, note the starting and end points. A translation of a plane along a given vector is a basic rigid motion of a plane. The three basic properties of translations are as follows. In a translation, which is a slide, a translation maps a line to a line, a ray to a ray, a segment to a segment, an angle to an angle. The second rule, a translation preserves lengths of segments. So the length in the segment of the figure is the same as the segment of the image. And the third rule, a translation preserves the measure of angles. So if the figure is 31 degrees, then its image will also be 31 degrees.